Okay, I'm gonna try this. I'm outside in the garage and it sounds like a lot of people are doing some gardening. So I will see if this works out for us. But this is Miss Griffith and we're gonna go over topic 4.2, nominal versus real interest rates, a topic that you've actually seen before. When we were in class a while back, we discussed what are interest rates. Okay, well this is the rate that you're gonna get paid back in addition to what you actually lent the borrower. And why do lenders charge them? Well, they need to make money. You can't just lend all of your money away and not charge an interest rate. I once upon a time back in H1 said, who is willing to lend me $100 if I will pay a total interest rate of 100%? And most of you raised your hand. You raised your hand because I'm gonna pay you back that original $100 plus 100% interest, which is another $100. So essentially you're making $100 off of loaning me $100. All right, when we read the fine print, however, when I said I plan to pay you back in 2050, a lot of hands went down. Why? Because you do not know how the interest rate is adjusting in the future. All right, so in order to get the real interest rate, we need to know the nominal interest rate and the inflation rate. All right, so if the nominal interest rate is 10 and the inflation rate is 15%, how much is the real interest rate? Well, that's just gonna be 10 minus 15, which equals a negative 5% here. All right, we have two formulas. We have the real interest rate. This is the percentage increase in purchasing power that a borrower pays. It is adjusted for inflation. So essentially the real interest rate is the nominal minus expected inflation. That's what we just did here. We did that the real interest rate equals nominal minus inflation. And then if we knew the real interest rate and the expected inflation, we would be able to calculate the nominal interest rate. The nominal interest rate is the percentage increase in money that a borrower pays. It's not adjusted for inflation. So in order to calculate nominal, you are just going to add the expected inflation to the real interest rate. Here's a bit of a visual here that Clifford provides us. This is just saying the nominal interest rate equals the real interest rate plus the inflation rate. Next, we have some fill in the blanks. It gives you two of the following, either nominal interest rate, inflation rate, and real interest rate, and wants you to fill in the blank and on the unknown. So we know that real interest rate plus inflation rate must equal to nominal, okay? So nominal has to equal the inflation rate plus the real interest rate. So here I say 8 plus what is going to equal 10%, and that is simply 2%. Next, we have 12 plus a negative 4 is going to equal the nominal interest rate. That is 8%. Next, we have a number plus 7 is going to have to equal 12. That would be 5%. And next we have 10 plus what is going to have to equal 7%. Well, that's actually going to be a negative 3%. Number 5, we have 7 plus what is going to equal 5, and that would be negative 2%. Next one, we know that 6 plus a negative 2 equals a nominal interest rate of 4%. All right, let's think about this question. Would you rather have $100 today or $200 in 5 years from now? Well, in order to answer this accurately, you would need to know about the interest rates and about inflation, because we're really focused on the real interest rate, which has to do with the nominal interest rate and inflation. Remember that real is adjusted for inflation. Let's look at a few examples, and these have to do with a formula you have probably seen. You can determine the future value of any amount of money if you know the interest rate and the number of years. So Clifford sets it up a little bit differently than I do. I like to set it up A equals P. A is for the future amount you will have. That's going to equal the principal, the amount you start with, times the multiplier to the t power, or in his case, the nth power. How many years? Okay, years. And the multiplier is simply 1 plus the interest rate. The interest rate would be in decimal form. So if we wanted to compute this example, they say the interest rate is 10%, or 0.10 if you put it in decimal form. Then the future value of 100 is 110. Well, how did they get that 110? Well, we're plugging it into our equation, so that's going to equal the principal, how much we start with. That's 100, and times the multiplier, 1 plus the interest rate in decimal. The interest rate in decimal is 0.10 to the first power, because we want to know about 1 year from now. Well, after we do this calculation, we see that A, the future value, or Clifford just calls it, I guess, the future value, A would be 110. Okay, so maybe you have this $100 in a bank account and the interest rate is 10%. Well, your banking account will grow to 110 with this particular interest rate. Or if you loan $100 out to someone, and by the time they pay you back in 1 year, you will have made $10 on that loan. What is the present value? So we're actually looking for P here. In 1 year, if the interest rate is 10%. Well, we want to solve for P. In order to get P isolated in the equation I wrote, we would divide both sides of the equation by 1 plus the interest rate to the t power. So that's just what I have done here. I did the principal equals the future value divided by 1 plus the interest rate to the t power. Well, we want to see what the present value is when our future value is 100. So I'm plugging 100 into A and dividing it by 1 plus 0.10, because 10% is still the interest rate, to the first power, because we want to see how much the present value of $100 is worth in 1 year. When you calculate that, you get that the present value of the $100 is 90.91. So that means that the future value of 90.91 when the interest rate is 10% would be $100. Again, these type of questions aren't asked too much on the AP exam, but these are valuable equations for you to know. They might come up, they might not, but they definitely will come up in your life. All right, thank you.